Well, hello everyone, and welcome back to another video from the Canal Sidings Model Railway channel. This time it's testing the automatic braking, and I have to say, so far so good, but there's still a long way to go. So what I've got here is laid on this bit of grey foam, because it gives you a decent contrast to everything that's behind it, is my first lash up of the whole system. Now bear in mind that it consists of the control panel, which is essentially this bit here, whoops, and one signal, which is this bit here, and a switching relay. Over here we have something else which is not anything to do, which is not either of those or any of those, which I'll come to in a minute. And also bear in mind that there is only one signal in use on that board, and there's only enough wiring for one signal, and that I haven't got all of the wiring off of this control panel to go to all the other signals, etc. So there's a lot more wire to end up in this, although hopefully it'll be shortened to the right lengths and will not be a hodgepodge of bits going all over the place. But I'll briefly explain to you what everything is. You've seen the control panel a couple of videos ago, well actually last video as well, because I fixed some speed measurement errors in it, and this is it without any changes. There is the I/O expander, which at the moment I'm only using one output on, but there's plenty more out there. Are 6 outputs on there that and there are 2 spares which I haven't used yet. So what this is doing is simply taking in, as we saw before, a sensor signal there, which is the signal sensor, which is up that way over there somewhere, and another sensor from here, which is the signal that is, sorry, the sensor which is over there, which is the braking sensor, if you like. And remember, this board looks at those as the start and stop of speed measurement, so it uses them the same at the same time, but for different purposes, to the signal board, which is there. The signal board is something like you've seen before. It was about 2018 that I first showed my take on semi-automatic signals that followed the trains around, and since then I've been adding functionality to it to make it a little better, and again about 2 or 3 videos ago you saw my attempt at using braking to stop trains, even though it's DCC and we don't actually know what the address of the loco is. And we looked at asymmetric braking control, which relies on the decoder, which I don't have those decoders. I do have some Zimo decoders and some Locksound decoders, but not all my locos have high quality decoders like that. You would need either one of those or a lens decoder, gold or silver I think, in order to be able to have automatic braking control. That's ABC, asymmetric braking control, built into the decoder. Too expensive for me. That means changing most of my decoders. I'm not prepared to do that, as we've said before. So what I've come up with is I tried brake on DC, but that was a complete failure. Most of the decoders don't actually do it properly, and it's not very well sorted at all. So I'm using the third method that we talked about, which was to be able to brake by switching the braking section where the locomotive is into a different command station, DCC command station, which is outputting a broadcast stop packet, to which any loco will respond by slowing down and stopping according to the deceleration set in CV4 and its speed to start with. A bit of a mouthful, all that. Okay, so in order to switch command stations, we need this, which is the relay module, which has two relays on it, and they're both used for the same piece of track because they're only single pole changeover relays. This came from a company called AZ Delivery, I think. You can get them on Amazon and or eBay. Not sure whether it's both or either or one of them, but that's where they come from. They're reasonably well priced. And I've also, to the signal board, added an I/O expander, which is the same as the one I've got over there, and I'm using two connections on that, and that is because I've added so much functionality to the signalling capability. So what happens when a train arrives in the braking block is what I'm trying to say. When a train arrives in a braking block, the braking sensor alerts the signals to say, hey, there's a train just arrived. The signal block looks at the signal and says, the signal's red. Braking is enabled from here, if there's a yes in there, which is done by the control panel, so I can switch it back to manual mode. And we're not already in a braking phase, which is another variable, then switch the brakes on, which what happens is it drives these relays directly off the Arduino. They've got opto couplers in them, so they will drive directly off the Arduino, and that switches between the two command stations. The two command stations come in on that pair of wires there, which is, can you see those? That pair of wires there, which go off to a sprog, and this pair of wires here, which come from my power cab, as it is at the moment. This goes off to all the other track, and the two wires that are and that let me rephrase that. Yes, this goes off to all the other track, but the section over there is controlled on these two wires and can either be switched in to the power cab, or it can be switched in via a pair of wires here. I can hardly see them. I'm in an awkward position here. It's this pair of wires, right, I can see them now. This pair of wires here, which switch in the sprog. So this board here just joins wires together. It doesn't do anything else apart from these two bulbs. And those two bulbs are quite important because under a fault condition, it is quite possible for the output of the power cab and the output of the sprog to end up joined together. Now, if both tracks, I'm just looking for something, if both of the tracks rails, I'm trying to, so I'm falling over things now. If both of the rails are shorted together, what happens is, I'll try and do it. That's one rail shorted, doesn't do anything. That's the other rail shorted. Oh, by the way, I haven't. So I need to trip. I'm trying to find my way around the camera. What I'll do is I will trip the braking sensor to come on. So pretend there's a train coming. Right, you see the lights on here have now come on. There's one there and there's one around the back, saying that both relays are picked. We have now switched the braking section into the sprog. So what I can do now is I can short the rails of the two together. That's one rail shorted, doesn't do anything. That's the other rail shorted, doesn't do anything. However, if I short both rails together, can manage it. Oh dear, I can't do it. Can't reach. That's what I get. The bulbs come on and avoid blowing up or tripping out the controllers. And that didn't trip, and the sprog didn't trip. So they're safety measures, and they're actually quite a good way of limiting current. What they are two 21 watt, typically brake light or rear light bulbs for cars, 12 volt. They're becoming harder to get nowadays, and people are trying to sell them at exorbitant prices. I bought a pack of 10 for about £3, so it is possible. That was on eBay somewhere, and I'm going to use some more of them because I'm going to use them in other sections of my track in future, and I'm going to have a box which has them all in, all visible, so that any that trip you'll be able to see immediately, and it will tell you which one has tripped. So you know where you've created a short. But that's another story. That's all that is for, and they are just in series with the output of the sprog. So the sprog isn't connected directly through the relays to the track, it goes through those bulbs in series. One bulb on each rail. So that is essentially what I've got here. I have one signal in the system, which you'll see when I move the camera, and that is running off of here as well. It's at the end of the braking section that I've got set up, and it has a delay sequence on it, so that after it goes red, then as soon as the reason for it being red has disappeared, it will scroll through yellow and green about 5 seconds apart. Otherwise the signal gets stuck at red and you can't do anything, and that's what happens with terminus signals if there's nothing following it. So we've been through all that. You need to go back to my 2018 videos. There's a lot of videos been done on this sort of thing, and I've talked about it a lot. But what I'm going to do now is I'm going to move the camera down that way, like where it was in the last videos that you looked at, down there, so that you can see the braking sensor, the signal and the signal sensor, and you'll still be able to see most of this, and we'll actually show it working. So back in a minute. Okay, here we are with the camera in a different position now, and you can see, hopefully, right down there is the signal, and the signal sensor is behind it by that piece of card. Just here is the braking sensor, where the brakes will be applied if the signal is red. And I have a loco without sound. We'll just run the loco and I'll talk you through what happens. I'm going to change the signal with my trusty remote control, and I can do that from standing where I am, so I don't need to touch the loco. I can just change the signal to red and take it away from red whenever I need to. So that's all I shall be doing, deciding whether the signal's red when the train arrives or not. So I'm just going to go down the other end now and make the train run. The first run we'll take through, we will have a green signal and nothing should happen. The train is consists of some hoppers. It's a completely different train. It's got a class 37 on the front, one of the class 37s that you saw when I was experimenting with switching this around. On the rear it has got a couple of track cleaning vehicles, because the track has been quite dirty in places, so I've actually been using them to keep it clean and doing my usual no track cleaning fluid, don't like most of them, simply use graphite off of a 4B pencil or a little bit of graphite powder. And I've rubbed graphite into the cleaning pad of that Bachmann cleaning vehicle right on the back, that along with that other device you saw, other wagon that you saw there, which is the black one on the end, is going to form two vehicles of a cleaning train that I'm going to put together, which I'll be able to run around at any time. But at the moment I'm just using it on the back of that train to keep the track clean while we do all of this. Okay, so you saw the train run through there, and it went through at 26.4 miles per hour. So what we'll do this time, and didn't stop, what we'll do this time is we'll change the signal and get it to stop. The train's just arriving. When it passes this sensor close to the corner of the camera, click, and you see a light comes on down there. Oh no, you might not be able to see that, but there was a click, and what's happening is the train is slowing down, ready for a stop at the signal. And there it is, and I'll just go and check where it stopped. Yeah, it stopped with the nose of the train about 30 to 40 millimetres in front of the signal, so hasn't passed it. And we'll sit there until the signal goes away from red. It can go yellow or green. I can only set it to green from here, but it could be that it was a signal down the track, and after that signal has cleared, then this would go to yellow. If that signal was red, this signal would go to yellow, and then would go to green if that signal cleared to yellow. You've seen all that before in a lot of videos ago, 2018 as I say. So what I'll do is I'll start the train, the signal will change, there'll be about a 4-second delay, which I've put in to allow for the crew, the loco man, to get the loco ready to move again, and then you'll hear a click, which is the brakes going off as the two DCC command stations are switched around. Then the loco will start. So here we go. There's the click, and off goes the train. And of course the signal goes red again, because there's now a train the other side of it. It's taken over the next section. And of course I left the signal green that time, so the next time round the train will just go straight through. If I set it red again, the train will stop again. So what I will do is set it red and say nothing, and you can just watch it all happen. So there we have it. Automatic braking in front of a red signal. As you saw with all the hardware, this is not for the faint-hearted. There is a lot of wiring to do to get it to work, and I am sure there are other ways of doing it. If I was an expert on JMRI, I could probably use JMRI to do it. But I'm not an expert on JMRI, but I am an expert on Arduinos, so that's what I tend to use. They're very cheap, and I've got total control over them, so if they break I can easily replace them, and if I get the software wrong I can put it right. So what we'll do now is we'll just take the experience one step further, and we'll demonstrate it with a loco with sound, and then we'll wind the video up. So back in a mo. Okay, I've changed the loco. This one has got sound and a Zimo decoder. So we'll just watch that and get the full experience, and then I'll wind the video up. We'll do a run through first with the signal green, and you can see that it just passes it. It'll also measure the speed. That was about 28.5 miles per hour. Okay, this time with the signal red. So we've stopped just short of the signal, and we'll set the signal back to green. Little delay as the driver gets ready. There we have it, a train with sound doing all the right things and stopping automatically at the signal. The only thing I did, as before, was operated the signal with my little remote control, which is there, like I'll do again. Signal red, single green. And you've seen the little remote control which drives the board before. So that's it. That loco has a Zimo decoder and was set at almost the same speed step. In fact, I think it was exactly the same speed step. Yes, set at exactly the same speed step as the last loco, which had a Hatton's MD4 decoder in it and no sound. The Hatton's loco was set, that speed step 52 is where we were running. The Hatton's loco had CV4 set to 30 I think. Just get my trib sheet. Yep, CV4 was set to 30, whereas the Zimo decoder has got CV4 set to 68 to stop at approximately the same time. So we can see that there is only one speed and deceleration per loco that is going to stop it in the right place. But my brain is already now whirring on a way to possibly mitigate that by using another Arduino which works out which locos are on the track at any given time, looks at the speed that they're running at, or the speed step they're running at, and calculates from a known table of values what value to put into CV4 to ensure that the train will stop correctly at the signal. But that's a long way off, another story and a lot of bug fixes later. So watch this space. Anyway, thank you for watching. I hope you've enjoyed the video. Hope it's not been too technical, but it does demonstrate that you can do automatic braking without changing all the decoders in your locos. And I know a lot of you out there have probably got 100 locos and would not want to change all your decoders to £30 lens decoders unless you already use them, in which case everything would be fine. So, thank you very much. I'll see you soon. Bye.